Hello everybody, welcome to our new chapter, Heron's Formula. Have you ever come across this great mathematician Heron before? Let's have a look about him. This is Heron. His real name was Hero. Later on, he came to be known as Heron of Alexandria. He is a Greek mathematician. His native place was Egypt. His main work was on applied mathematics, and one of his main book is related to the area, surface area, volume, and details about polygons. Here in grade 9, you have to study the area of a triangle based on 3 sides. In smaller classes, you have studied about area of a triangle as half times base times height, where you have base and height. But here you have all the 3 sides, but nothing is given about the height. That's what we have to look. And let's get into the lesson. Area of a triangle from the smaller classes is half times base times height. That itself has 3 cases. In an acute triangle, you have a base and we have the height inside the triangle. In a right triangle, we should have the base and the height will be on the triangle. And in an obtuse triangle, we'll have the base and the height will be outside the triangle. Let us see one by one. Here, this is the base and here is the height. Half times base times height. Again, in a right triangle, half times base times height is on the triangle. Here in an obtuse triangle, few students get confused. How can it be outside the triangle? Yes, this can be the base and it can be extended for understanding only. This line is not as a part of the area. The base is from the starting point and this is the end point. And the height can be outside the shape because height is the distance from the opposite vertex. Here base is here and this is the vertex. So the area is half times base times height. Let us see an example. Here we have a right triangle. We need to find the area. Area of the triangle is half times base times height, or base times height divided by 2. We have the base, but height is missing. In such situation, we have to apply Pythagoras theorem. By applying Pythagoras theorem, we have hypotenuse. Square of the hypotenuse is equal to square of the base plus square of the height, which is 169 is equal to 144 plus h square, or h square is equal to 169 minus 144. H square is equal to 25. Taking square root on both sides, you will get h is equal to 5. Let us say all of them are in meters. So area is equal to base times height divided by 2, which is 6 times 5, 30 meter square. That is the area of this given triangle. Remember, we are only using height and the base. We are not using the hypotenuse to find the area of a right triangle. Moving on to an equilateral triangle. You know, in an equilateral triangle, all sides will be equal. Let us represent it by the letter A. Actually, this will be used in the higher class. Just for your information only. There is a rule for finding the area of an equilateral triangle. The rule is √3 divided by 4 times A square. Imagine A is 10. So area is equal to √3 divided by 4 multiplied by 10 times 10. So which is 100. Therefore, area is equal to 100 divided by 4 is 25. So 25 √3 meter square, for example, if A is equal to 10 meters. If so, the area is 25 √3 meter square. Now moving on to the real objective of the lesson, to understand Heron's formula. Before we understand Heron's formula, let me give you a quick review of naming the sides of a triangle. Sides of a triangle can be named in 2 ways, either by 2 capital letters marking the starting point and the ending point of the line segment, and even it can be represented by showing a line segment above, or it can also be represented by one small letter. But which small letter are we using? When we use the small letters, it should be the letter which is opposite vertex. Here, if we are using BC as the side, the opposite vertex is A. So the side should be represented by small letter A. To side AC, vertex B is opposite, so small letter B. To side AB, vertex C is opposite, so small letter C. These are the representations of the sides. If one letter, it should be small letter. Now, getting into Heron's formula, at first we have to see perimeter. You know, perimeter means add all the sides. So here perimeter is A plus B plus C. And what will be semi-perimeter? Semi-perimeter means half of it, which is represented by S. This is very important in Heron's formula S. S means semi-perimeter. So at first we add all the sides, A plus B plus C, then semi, so half of the perimeter. This is important. And therefore, area of a triangle using Heron's formula is square root of, remember, the whole expression is inside the square root, semi-perimeter times S minus A times S minus B times S minus C. Let us see with an example. Here we need to find the area of the triangle ABC. We are only given the sides. Instead, if you have the height, let's say a height is 7 meters, then we can just write 8 times 7 divided by 2. That's it. But here we have no idea about the height, so we have to apply Heron's formula. And remember, Heron's formula starts with perimeter. We add all the sides, 5 plus 5 plus 8 is 18 divided by 2. So semi-perimeter is 9 meters. Now let's write the rule for finding the area using Heron's formula. A is equal to square root of semi-perimeter multiplied by S minus first side, S minus second side, S minus third side, which is equal to square root of semi-perimeter is 9, 9 minus 5, 9 minus 5 again, 9 minus 8. These are the three sides, which is equal to square root of 9 times 4, again 4 and 1. And instead of multiplying all the numbers, we can take one by one outside. Square root of 9 is 3. Square root of 4 is 2. Again 2. And square root of 1 is 1. Therefore, area of this triangle is equal to 3 times 2 is 6. 6 times 2 is 12 meter square. Great. Let's move on to exercise 12.1, first question. Find the area of a traffic signal board, which is an equilateral triangle. Equilateral triangle, all sides are equal. And we are not given what's the measurement of each side. But we are given the perimeter. A plus A plus A is 180, or 3A is 180 centimeter. So we can get A is equal to 180 divided by 3, 60 centimeter. So each side is 60. Now, before we use Heron's formula, we need to get S, or semi-perimeter. Semi-perimeter is 180 divided by 2, which is 90 centimeter. Now we apply the area of a triangle using Heron's formula. Area is equal to square root of S times S minus A, S minus B, S minus C, which is equal to semi-perimeter is 90. 90 minus each side. So 90 minus 60, 90 minus 60, again 90 minus 60. All of them under the same square root, which is equal to square root of 90 times 30 times 30 times 30, which is equal to, from 2 30s we can take 130 outside, and then we have square root of 9 times 3 is 27 and 2 zeros, which is equal to 30 times From 27, we can take 9 outside. So we can rewrite 900 times 3, which is equal to 30 times 900 will give another 30 outside, because 30 times 30 is 900. Or we can say square root of 900 is 30. So we have one more 30. This is gone with root 3. Root 3 is an irrational number, so we can keep it as it is. 30 times 30 is 900, root 3, and don't forget the unit. So 900 root 3 centimeter square is the area of this traffic signal board. Hope it's clear. And we will continue the exercise in the next period. That's all for today. Thanks for watching.